it is not required. I think you know all this as the constant a naught by 2, which is, and an is a coefficient of cost constant, a cost component, and bn is the constant related to sine components. Okay, so this is the way we find the values of a naught, a and bn. Okay. Yeah, what is this Dirac delta function? If any periodic function whose length is 2L, which can be expressed as the Fourier series, what it should be? It should be a finite number of discontinuous within the period 2L. Okay, and it should have a finite average value over the period 2L. It has a finite number of positive and negative maxima minima. When the conditions are Dirac delta conditions, the Fourier series can be expressed in terms of f of t. What and all should be there? It should be discontinuous within the time interval, and it should be periodic with the average value, and it should contain finite number of positive negative intervals or maxima minima values of the function. Then it can be expressed in terms of f of t. So when it is a square wave function, how we can sketch the 3 cycles? That is, f of t is raised from -4 to 0, which is 0, and 0 to 4, it is 5. So it can be expressed as f is equals to ft plus t, ft plus 8, and find the Fourier series for this function. So this is what is the sketch related to it. So what we need to do is, we need to have a value 0 to 4 maximum, then 5 to 8. It is repeated because they are given f is equals to f of t plus 8. The periodicity is 8. For every 8 interval, it is going to repeat the sequence. So you can find the coefficients by taking this interval. A naught is what? 1 by L integral minus L to L ft dt. What is L? 2L is 8, or you can take it as a time period. 2t is equals to 8. Then what happens? T is equals to 4. So A naught can be calculated as 1 by L integral minus L to L f of t. So it is 1 by 4 integral minus 4 to 4 ft. Okay, so what the value we have in the signal? -4 to 0, it is 0. 0 to 4, it is 5. Okay, so that is repeated. So we got the constant as what? Of 5. So then we need to find the an and bn. Okay. The formula is 1 by L integral minus L to L ft cos of n pi t by L. So, okay. Okay, calculate the coefficients of an and bn using this formula. Okay, all of you know to calculate that. Do it, and you're going to get the component or coefficients for the signal. Then you're going to get the coefficients for the signal bn. As we have only bn and a naught components, we substitute and we are going to get the equation. Okay, this is in terms of n. So substitute the n, you are going to get the values for different cases, n equal to 1 to solve what the values are. Substitute that, you are going to get actual Fourier series ft. Okay, if 0, if n is even, you are going to get this one. Else you are going to get the values as, you can write it 10 by 2n minus 1 pi. Okay, the series becomes odd, or if the series becomes even. This is what is the multiples of the signal. Okay. As a yeah, this is what is common period. You will take it as 2L is equals to. This the range of the graph is in terms of 40 milliseconds. You can repeat it. Wait. It's not required. Yeah, 1 second. Yes. See, when signal is periodic, we say Fourier series. So we form with periodic signals is with the period t is denoted as v of t is equal to v of t plus t, which is a periodic signal. As we have seen, you can express this in the terms of trigonometric series. A naught a1 cos 2 pi t plus b1 sin 2 pi t, which from 0 to infinity. If you take only the positive uh, infinite series. B naught is assumed 0. This infinite series will convert to only the mod of AK and AK to both the values in infinity range. Okay. So V of t can be written as 0 to k. If it is a finite quantity for finite time period, we can take it as A equal to 0 to k, AK. That is small k is equal to 0 to capital K. AK cos 2 pi k by t plus BK sin 2 pi k by t. Okay. Then the fundamental frequency is what? It is a reciprocal of the time period. So f naught is equals to 1 by t. So Fourier series is expressed as 0 to infinity ak cos 2 pi k f naught t plus bk sin pi k f naught t. If this signal f naught, we said it is a fundamental frequency. If this fundamental frequency is multiplied by some component or a constant, then that frequency is called as an harmonics of the fundamental frequency. Already studied communication, which is called as fundamental and harmonics of the fundamental frequency. Okay. Okay, a square wave is approximated for the finite Fourier series with an increasing number of terms. So it is analysis of Yeah. A naught is given by this. A1 is given as 2 by t. These are called as a Fourier coefficients. Okay, using these Fourier coefficients, you are going to express the signal. First, 1 second. Yeah, we given an